Every deep space phenomenon in this video has been measured, photographed, or survived by a real person, and every single one sounds like we made it up. We're covering 9 of them, starting with boiling saliva and ending with something so horrific it made seasoned astronauts genuinely lose their minds. Let's go. Number 1. Your saliva boils first. We know exactly what happens to a human body in the vacuum of space, second by second. Not because we guessed, because it's happened to real people. Here's the timeline. You get 9 to 12 seconds of consciousness. That's it. Your body swells to roughly twice its normal volume. Your heart hits cardiac standstill in 10 to 15 seconds. After 90 seconds, you're almost certainly dead. But here's what Hollywood gets wrong. You don't explode. Your skin and connective tissue are way stronger than that. They hold. You also don't freeze instantly. There's no air in vacuum, which means no convection, no conduction. Heat barely leaves your body. You die warm. What actually gets you is the pressure drop, and the first thing to go is your spit. 1966, NASA vacuum chamber. A technician named Jim LeBlanc is testing a spacesuit when the pressurization hose disconnects. Full vacuum. His last conscious memory before he blacked out was the feeling of saliva boiling off his tongue. Not hot boiling, pressure boiling. At low enough pressure, liquid boils at body temperature. The chamber was repressurized in about 30 seconds. LeBlanc woke up. He went home for lunch. He tasted his own blood boiling and then had a sandwich. 4 years earlier, Joseph Kittinger rode a balloon to 102,800 feet for Project Excelsior. During the ascent, his right glove failed, lost pressurization completely. His hand swelled to twice its normal size. He could feel it happening. He said nothing to Mission Control because if he reported it, they'd abort the jump. So he rode it out, hand ballooning inside the glove for the entire ascent. After descent, his hand returned to normal. He completed the jump, but the worst case already happened. June 30th, 1971, Soyuz 11, 3 cosmonauts, Dobrovolsky, Volkov, Patsayev, undocking from the Salyut 1 space station. During module separation, a cabin ventilation valve jolted open. The cabin depressurized in seconds. All 3 were found in their seats when the capsule landed. No pulse. Autopsies showed hemorrhaging in the brain, the lungs, the middle ear. Gas bubbles threaded through their bloodstreams. They are the only confirmed human deaths from vacuum exposure in space. After Soyuz 11, every crew wears pressure suits during launch and re-entry. That rule is written in blood. And the margin is thinner than you think. There's a boundary called Armstrong's line, the altitude where pressure drops so low that your body fluids start to boil. It's 19 kilometers up. Commercial jets cruise at 10 to 12. The distance between a normal Tuesday and the boiling point of your own saliva is about the height of Mount Everest, twice. This video just started, and there's already a man alive who knows what boiling blood tastes like. Number 2, your eyeballs are a particle detector. Close your eyes, all the way. Now imagine a flash of white light, a streak, a blob, a sharp dot, firing across the inside of your closed eyelids. Not a floater, not a pressure phosphene from rubbing your face. A genuine flash of light generated inside your eyeball by a subatomic particle moving at 75% the speed of light, punching through the jelly of your eye. Astronauts have been seeing these since Apollo. On Apollo 14, the crew ran a formal experiment. They turned off the cabin lights, covered their eyes, dark adapted, and just counted. 48 light flash events in 17 minutes. They see 3 shapes, a spot, sharp and sudden, a streak, a line dragged across the visual field, and a cloud, a soft diffuse glow, almost always white or colorless. One exception, David Scott on Apollo 15 described a flash that was blue with a white cast, like a blue diamond, he said. The average rate on lunar missions was 1 flash every 2.9 minutes. Just sitting there, eyes closed, getting shot through the head by the universe. The leading explanation is wild. These particles, heavy cosmic ray ions, are moving so fast that they actually exceed the speed of light inside your vitreous humor. Light travels slower through dense material than through empty space. When a particle outruns light in a medium, it produces a specific kind of radiation called Cherenkov radiation. That eerie blue glow you see in footage of nuclear reactor pools, that's Cherenkov radiation in water. This theory says the same thing is happening inside your eye. A tiny nuclear reactor glow in your skull from a particle that left an exploding star 1,000,000 years ago. But there's a problem. Cherenkov radiation is blue. Most astronauts report white flashes. After 55 years, the mechanism still isn't fully settled. Don Pettit, who spent months on the International Space Station, described it like this: flashes in his eyes like luminous dancing fairies in the dark confines of his sleep station as he drifted off. He said it was beautiful. Then he mentioned that the same cosmic rays destroyed camera sensors aboard the station. After a year in space, photos came back covered with electronic snow, permanent damage to the hardware. So NASA asked the obvious next question. If these particles are generating visible flashes in the retina, interacting with visual neurons hard enough that you can see them, what are they doing to the rest of the brain? Nobody has a comfortable answer yet. Number 3, the galaxy's fastest bullet. Somewhere in the constellation Grus, 29,000 light years from Earth, a star is running. Not orbiting, not drifting, running, at 6 million kilometers per hour, fast enough to cross from Earth to the Moon in about 4 minutes, 10 times faster than most stars in the Milky Way. Its name is S5HVS1, and it will never stop. It's moving fast enough to escape the galaxy entirely, permanently. We traced its path backward using satellite data, ran the orbit in reverse. Every trajectory line converges on one point, Sagittarius A star, the supermassive black hole at the center of the Milky Way. Our black hole shot this star. The mechanism is called the Hills process, and it works like this. A binary star system, 2 stars orbiting each other, wanders too close to the black hole. Gravity grabs one star. The other gets launched, catapulted outward like a stone from a slingshot at nearly 2,000 kilometers per second. The math says S5HVS1 was ejected about 4.8 million years ago. On Earth, at that exact moment, your ancestors were just learning to walk upright, and this isn't rare. The estimated ejection rate is one hypervelocity star roughly every 10,000 years. Over billions of years, that means thousands of former Milky Way stars are now drifting through intergalactic space. No galaxy, no neighbors, just the void forever. The black hole at the center of our galaxy has been firing stars into the dark since before Earth existed. Most of them we'll never find. Number 4, 20 invisible planets for every star. There are planets in this galaxy with no sun, no orbit, no system, just a planet. Alone, moving through interstellar space in total darkness. They're called rogue planets, and there are a lot of them. Current estimates put the number around 4 trillion in the Milky Way alone, possibly up to a quadrillion. That's roughly 20 rogue planets for every star you can see. The galaxy is not mostly stars, it's mostly wanderers. They form 2 ways. Some get ejected from young, chaotic planetary systems, gravitational pinball during the messy first few million years. Binary star systems alone are estimated to kick out 2 to 7 Earth mass planets each. Ejection speed 8 to 16 kilometers per second, fast enough to never come back. Others may form directly from collapsing gas clouds, the same way stars do, just not enough mass to ignite. In 2021, astronomers found 70 to 170 rogues drifting through a single star-forming region. Largest batch ever detected at once, but that wasn't the strange part. In 2023, the James Webb Space Telescope found something in the Orion Nebula that no one predicted. About 40 pairs of Jupiter-mass objects orbiting each other with no star. They got nicknamed jumbos, Jupiter-mass binary objects. And they're a problem. If these were ejected from star systems, the violence of ejection should have ripped the pairs apart. If they formed on their own, like stars, there's no known mechanism that produces objects this small in pairs. 2 years later, nobody has a clean explanation. Now here's the part that gets personal. A team out of Harvard calculated that our own solar system may have already captured rogue planets. Roughly 2.7 Mars mass objects could be orbiting the sun right now, out at about 1400 astronomical units, way beyond Pluto, gravitationally bound to us, completely invisible. The odds of a rogue planet actually entering the inner solar system are tiny, about 1 in a trillion within the next 1,000 years, but a Jupiter mass rogue passing even within 100 astronomical units could gravitationally disturb the Oort cloud and trigger comet storms that last millennia. The scariest thing in the galaxy isn't what you can see, it's what's already here that you can't. Number 5, pulled apart like pasta, with real math. You've heard of spaghettification. It gets thrown around in every black hole video like a fun quirk. It's not a quirk. Physicists have calculated the exact distance at which your body comes apart, and the answer depends on the size of the black hole in a way that breaks your intuition. What kills you isn't gravity, it's the difference in gravity. The pull on your feet versus the pull on your head. That difference is the tidal force, and near a black hole, it gets absurd. At 100 kilometers above a solar mass black hole, a small one, the collapsed corpse of a single star, the tidal force difference between your head and your feet equals roughly 6 million times Earth's gravity. You'd need to stay at least 700 kilometers away to survive. Any closer and you're done. Stretching first, then lateral compression, your body squeezed sideways as it's pulled lengthwise. Then, circulatory failure, spinal separation, atomization, seconds, maybe minutes. Now here's the twist. Supermassive black holes are safer. Sagittarius A star, 4 million solar masses, has a tidal force at the event horizon that's about 1,000 times weaker than what you feel standing on Earth right now. You could cross the event horizon and feel nothing. No stretching, no pain. You'd be completely doomed. Nothing escapes from inside, but you'd be comfortable. For a while. Scale it up further. A 3 billion solar mass quasar black hole. The event horizon is roughly twice the diameter of our entire solar system. The kill radius, where tidal forces actually destroy you, is well inside. You'd be trapped long before you felt a thing. We've watched this happen to stars. They're called tidal disruption events. A star wanders too close, gets shredded into a glowing stream that spirals into the accretion disk. First observed in the 1990s, dozens confirmed since, now. Neutron stars, a different kind of nightmare. A neutron star is only 20 kilometers across but packs more than the mass of the sun. If you fell from 1 meter above the surface, you'd hit it in 1 microsecond, traveling 7.2 million kilometers per hour. Your atoms wouldn't just be destroyed, they'd become part of the neutron star. The terrifying thing isn't the big black holes, it's the small ones. Those kill you while you can still see it happening. Number 6. A teaspoon that weighs 1 billion tons. A neutron star is what's left when a massive star dies and gravity crushes the core so hard that protons and electrons fuse into neutrons. What you get is 1.4 solar masses, or more, squeezed into a sphere about 20 kilometers across, the size of a small city. A teaspoon of this material weighs 5.5 trillion kilograms. That's about 900 Great Pyramids of Giza. A sugar cube, 100 billion tons. A cubic meter is roughly the mass of the entire Atlantic Ocean. If you compressed all 8 billion humans on Earth to neutron star density, everyone who has ever argued with you online, everyone you've ever loved, every person alive, they'd fit inside a sugar cube. Surface gravity is over 200 billion times Earth's. Escape velocity is more than 1/3 the speed of light. The atmosphere, they do have one, is a few micrometers thick. The fastest known pulsar, PSRJ 1748-2446 AD, spins 716 times per second. That's a city mass object spinning faster than your kitchen blender. At the equator, the surface is moving at a significant fraction of the speed of light. If you could somehow stand on it, you'd be flung off faster than a bullet. And the inside might be even stranger. Theorists think the interior of a neutron star could be simultaneously a superfluid and a superconductor at 100 million degrees. The actual equation of state, The relationship between pressure and density in the core is unknown. We cannot replicate these conditions in any laboratory on Earth. Every number in this section is peer-reviewed, measured, and confirmed. None of them feel like they should be. Number 7. 330 million light-years of nothing. In 1981, an astronomer named Robert Kirshner was running a redshift survey, mapping where galaxies are in three-dimensional space. He found a hole, not a dark nebula, not a shadow, a region of space 330 million light-years across that was almost completely empty. That's the Botas void. Where you'd expect 2,000 or more galaxies, there are about 60. The rest is just space for 330 million light-years in every direction. It's part of the large-scale structure of the universe. Galaxies aren't scattered evenly. They form a web of filaments and walls, with voids in between. The Botas void is one of those gaps, but it pushes the limits. Some scientists argue there hasn't been enough time since the Big Bang, 13.8 billion years, for a void this large to form through normal expansion. The best explanation is that several smaller voids merged over billions of years, but even that is uncomfortable. The galaxies that do live inside the void are strange. They evolved in near total isolation. They're gas-rich, still forming stars with irregular shapes, like galaxies that never grew up because they had no neighbors to interact with. Here's the part that stays with you. If Earth were at the center of the Botas void, early astronomers would have looked up and seen nothing beyond the Milky Way. No Andromeda, no galaxy clusters, no evidence that anything else existed. We would have had no reason to believe other galaxies were real until telescopes powerful enough to see hundreds of millions of light years were invented. Our entire understanding of the universe, the scale of it, the structure of it, our place in it, would have been delayed by centuries, maybe longer, and the Botas void might not even be the biggest. In 2015, evidence emerged of a void 1.8 billion light-years across, nearly 2% of the observable universe's diameter. Just gone. There's even a hypothesis, still debated, not confirmed, that we might already be inside a void. A 2 billion light-year underdense region called the KBC void. If true, it could be messing with our measurements of how fast the universe is expanding. The horror isn't what's in the void, it's what the void would do to the way you understand reality. Number 8. The zombie star. In 1975, physicist Kip Thorne and astronomer Anna Zhitkov proposed something that sounds like it belongs in a horror movie. A dead neutron star swallowed by a living red supergiant, surviving at the core. Wearing the larger star like a suit, a Thorne-Zhitkov object. From the outside, it looks like a perfectly normal red supergiant. Same color, same size, same brightness. But at its center, instead of a normal fusion core, there's a neutron star. Surface temperature exceeding 1 billion degrees, driving nuclear reactions that don't happen anywhere else in the universe. The giveaway would be unusual amounts of specific elements. Rubidium, lithium, molybdenum, chemical fingerprints of alien physics. Now, honesty check. These objects are still unconfirmed. Everything I'm about to say is at the edge between theory and observation. In 2014, a team led by Emily Levesque identified a candidate, a star called HV2112 in the Small Magellanic Cloud. It had the right chemical signatures. Zhitkov herself said she was extremely happy that observational confirmation had started to emerge. But in 2018, follow-up work cast doubt. The chemical abundances might not be unusual enough. Then in 2024, a simulation tried to form one from a realistic X-ray binary system. Instead of a stable zombie star, the neutron star collapsed into a black hole and produced something resembling an ultra-long gamma-ray burst. Formation may be even harder than anyone thought. If they exist, estimates suggest 20 to 200 could be hiding in the Milky Way right now. Stars that look alive, but are already hosting their own corpse. Some of the most terrifying things in the universe look completely ordinary, until you look inside. Number 9. The view that breaks astronauts. Every section in this video has been about what space does to matter. This one is about what it does to minds. There's a phenomenon called the overview effect. Astronauts look down at Earth from orbit and experience a cognitive shift. borders dissolve, nations stop making sense. They see a fragile blue marble and feel a sudden, overwhelming unity with all life. It's been described by dozens of astronauts since the 60s. Frank White gave it a name in 1987. That's the version you've heard. Here's the one you haven't. Since 1957, test pilots at extreme altitudes have reported something different, a feeling of total detachment, unreality, existential terror at the emptiness. It's called the break-off phenomenon, and the research into it was quietly abandoned in 1973. Alexei Leonov, the first human to walk in space, 1965, described it simply. "You feel an absolute loneliness," he said. "There's no sound, no air, only you and eternity." William Shatner flew to space on Blue Origin in 2021. He expected wonder. He got grief. He described the vicious coldness of space and said it filled him with overwhelming sadness, dread. He looked at the thin blue line of the atmosphere, and instead of awe, he felt terror at how fragile it was, how close the void was. A science historian named Jordan Bim has argued that astronauts face intense career pressure to report positive experiences, a culture of lie to fly. Negative psychological reactions to spaceflight may be systematically underreported, and NASA is worried about what comes next. From Mars, Earth isn't a big blue marble, it's a dot, barely visible. The overview effect might become the isolation effect. In the Mars 500 simulation, where 6 crew members spent 520 days in a sealed mock spacecraft, the 2 most stressed participants were involved in 85% of all recorded conflicts. That was a simulation, in a building, on Earth, with a door they could technically open. The final horror isn't out there. It's what happens to a human mind when it finally understands what out there means. Every phenomenon in this video was measured by a real instrument, survived by a real person, or observed by a real telescope. The universe didn't need to invent monsters. The physics was already enough.